Hello friends, today we'll be dealing with a very interesting topic, the periodic table. Now for a basic understanding, what is chemistry? Chemistry is essentially the study of elements, right? And till date, there are 118 elements discovered. And so it would be pretty much next to impossible for one person to learn all the properties of each and every one of those 118 elements, right? So that's why scientists decided to make it easy by classifying these elements into groups based on similarity in properties. So that if we know the properties of one group, we'll get to know the properties of all the elements that are there in that group. So now early chemists decided to classify these elements based on characters, properties, valencies, etc. But this kind of classification was very vague. So that's why in the early 19th century, Daubigny came up with this law of triads. Daubigny said that Daubigny essentially arranged these elements in increasing order of the atomic weights. And by doing that, he grouped these elements into groups of three known as triads, such that the atomic weight of the middle element was the average of the atomic weight of the other two elements. Like suppose we take the example of lithium, sodium and potassium. The atomic weight of sodium, which is 23, is the average of the atomic weight of lithium, which is 7, and the atomic weight of potassium, which is 39. But Daubigny's law of triads did not hold true for all elements firstly, and secondly, the properties of the elements that were grouped into these triads in some cases were found that they were not similar. So that was the demerit of Daubigny's law of triads. And after Daubigny came Newland, and Newland came with his law of octaves. So Newland does essentially the same thing. He did an increasing order of atomic weights in series of 8. And Newland said that the physical and chemical properties of elements is similar between the first element and the 8th element of that series. So that's called Newland's law of octaves. But Newland's law of octaves also has its demerits. Firstly, it was true to a certain extent until potassium, but it failed for heavy metals beyond potassium. For these transition elements, the Newland's law of octaves did not hold true. And secondly, Newland's law of octaves also failed to leave spaces for elements that were not discovered yet, for undiscovered elements. Now after Newland came Mendeleev, and Mendeleev was the first one who coined the term periodic table, and he was the first one to actually organize all these elements in the form of a periodic table with groups, vertical columns known as groups, and horizontal rows known as periods. And Mendeleev said that chemical and physical properties of elements are periodic functions of their atomic weights, right? Which means that if we arrange these elements in increasing order of the atomic weights, we find that there's a repetition of similar physical and chemical properties at regular intervals. So this phenomenon is called periodicity in properties, and the properties that are being repeated are known as periodic properties. Now there are many such periodic properties such as ionization potential, electron affinity, etc., which I'll be explaining in my next video. But for now, what is important to note is that because of this periodicity in properties, Mendeleev could actually predict the properties of some elements which have not even been discovered yet. So elements like scandium, gallium and germanium, these elements hadn't been discovered, but Mendeleev was able to predict their properties. And that's why in his periodic table, he was able to leave spaces for them. And he called them Eka boron, Eka aluminium and Eka silicon respectively. But Mendeleev's periodic table also had its defects. Firstly, it could not justify the position of isotopes. Now what are isotopes? Isotopes are atoms of an element having the same atomic number but different mass number. Now suppose chlorine, isotopes of chlorine have the same atomic number 17, but its atomic mass is different. So one isotope is 35 and the atomic weight of the other isotope is 37. Right? So according to Mendeleev's periodic table, if we arrange them in increasing order of the atomic weights, then chlorine would occupy 2 positions in the periodic table because its atomic weights of its isotopes are different, which should not have happened. And secondly, in some cases such as in cobalt and nickel, an element with a higher atomic weight appeared before an element with a lower atomic weight. So when we looked at it from the perspective of periodic properties, cobalt appeared before nickel. But if we look at it from the perspective of atomic weights, cobalt's atomic weight is higher than that of nickel, right? So it's not justifying the increasing order of atomic weights. So then in the 20th century, Moseley came up with the periodic table which we regard to as the modern periodic table which we follow now. Moseley made a very minor change. He said that physical and chemical properties of elements are periodic functions of their atomic numbers, not the atomic weights, atomic numbers. So when we classify them in increasing order of the atomic numbers, then the problem of the isotopes gets justified because atomic number of isotopes is same. So isotopes such as chlorine will occupy only one position in the periodic table. And also for cobalt and nickel, the atomic number is 27, which is less than the atomic number of nickel, which is 28. So even that problem gets justified. So Moseley's periodic table was able to do away with almost all of the demerits of the previous periodic tables. So friends, that's where we end today. In my next week's video, I'll be explaining about a few periodic properties and also about a few features of the periodic table. Till then, keep revising and keep learning.